Azo dye is a type of dye. Dye means pigment. Okay, dye means pigment, one type of pigment that should be colorful. There must be so many dyes are there. Introduction, that must be definition of dyes, that is dye is a colored substance that can be applied to a substrate. It a colored appearance. It gives a colored appearance. Okay. There should be sentence construction not correct. That is, it gives a colored appearance. The dye is nothing but that is a colored substance that should be applied for any substrate or any material to give colored appearance. Okay. The substrate may be textile fiber, paper, leather, hair, fur, plastic material, wax, cosmetic, foodstuff, medicine, so many things. We can better call substrate, that is material. That should be material. Okay. That is, instead of using substrate, we can use material. So the dye is a colored material that can colored substance that can be applied to any material to give a colored appearance. Okay. The material may be textile fiber, paper, leather, hair, fur, plastic material, wax, cosmetic base, foodstuff, medicine, etc. Okay. Dye is nothing but that is a color substance that should be imply some color to some materials. Azo dyes are the largest class of synthetic dyes. Synthetic dye means which can be prepared artificially, which are not found in natural sources. That should be found artificially, man-made. Their chromophore is aromatic system joined to the azo group. That is, must be their chromophore. Chromophore is aromatic system which having the high conjugation, high aromaticity, and that should be attached with azo group, and this can be impact the color intensity. Okay. And the common oxychromes are NH2, amine, NR2, and also OH, that is hydroxyl group. Okay. As we before know, we have to know the chromophore. Chromophore is the, that is unsaturated things which can be give some color intensity. Okay. As per example, benzene, as per example, that is conjugated something, conjugated, as per example, beta carotene, there must be lots of conjugation is there. So by this we can call their chromophore. That is double bond, more conjugation. So wavelength that should be goes longer wavelength. So that should be the range are in the visible range. So we see color. Okay. And oxychrome, that should be increase the intensity. As per example, NH2, OH and NR2, they having lone pair, they can be donate their lone pair on negative charges. Most of the cases they give their lone pair, and this lone pair give more delocalization of electron, so more intense the color. Okay. The usual method of preparation of azo dye is direct coupling between the diazonium salt and phenol or an amine. That is, must be direct coupling between the diazonium salt, that is N2Cl minus, with phenol or an amine. Okay. Azo dye are the largest class of synthetic dye. Their chromophore is an aromatic system that should be joined to azo group, that is N double bond N group, and the common oxychromes are NH2, NR2, OH, which who bears some lone pair. Okay. And the usual method of preparation of azo dye is nothing but that is direct coupling between a diazonium salt and phenol or an amine. Okay. Dye and color. Dye, for a substance to act as dye, certain condition that should be fulfilled. It must have a suitable color. Obviously, it give some color, so it should have a color. And must be able to fix itself or be capable of being fixed to a fabric. That should be where it implied, where it should be input in fabric, that should be fixed on it. Okay. And the fixed dye must have fastness property. Fastness property means to light, resistance to the action of water. Fastness to light, when light is introduced, it does not react at all, it does not give any other reaction. And resistance to action of water, that is when water are introduced, they are inert to the water, does not react with water. And dilute acid as well as alkali, various organic solvents such as diclinic. So water, dilute acid, alkali, various organic solvent. which are do not influence or we can say that is dye that should be inert to the water, dilute acid, alkali, various organic solvent, which must be used in dry clinic. Okay. Color when white light, that is 750 to 400 nanometer, that should be falls on a substance, the light may be totally reflected or totally absorbed, or maybe totally reflected or totally absorbed. The substrate has the color of the reflected light, means that is maybe the white light that should be falls on a substance. If all of the light absorbed, the color would be black. If all of the light emitted, the color will be white. But if portions of some light that should be absorbed, so they give the color of reflection of light. That is the color, that a complementary color can be arrive. Okay. So dye means the substance to act as a dye, that some condition that should be fulfilled. First one, it have a suitable color, there is no issue. Second way, it must be fixed on the fabric where it imparted. Okay. Third one, it have fastness properties, that is fastness to light and resistance to water, acid, alkali and some solvent. It does not react all of the solvent. Okay, it should be inert in nature. And color, that is when white light, that is must be 750 to 400 nanometer, that should be falls on a substance, the light may be totally reflected. If totally reflected, the light will be white, and if totally absorbed, light will be black. If some portion that should be absorbed, some portion are reflected, so the color bears of reflected light. And if the light is absorbed, it always gives the substance of its complementary color. Okay, complementary color. Now we have to know complementary color, means if color absorb violet, their complementary color is yellow, green. If blue, that is complementary color is yellow. If green blue, that is complementary color is orange. Blue green, that is complementary color is red. Green complementary color is purple. Yellow green complementary color is violet. Yellow, that is complementary color is blue, and orange, that is green blue, and that is red blue green blue green. So color absorb and their complementary color is this. Okay. So if violet color absorb, so the substance the substance should be the color, the substance should have the color, that is yellow green. If violet color absorb, the color would be produced yellow green. Okay. Okay. If the substance the color absorb blue, so the color we see that should be yellow. Okay. We always see their complementary color, not the color which light absorb. Okay. Okay. Now we know ordinary light, that should be white light, consists of 7 color. As we know, V gear, that is violet, V for violet, I for indigo, green, B for V gear, that is violet, indigo, green, yellow, orange and red. One is missing, I think blue, B for blue. Okay. And from short wavelength to short wavelength, that is high energy, to long wavelength, that is must be low energy. There should be B is missing. B is, I think, blue. Okay. Okay. That should be arranged, that is from short wavelength to long wavelength, or as we know, that is lambda inversely proportional to E, that is must be as we so we can say that is high energy to low energy. Okay. By passing white light through a glass prism, we can see 7 color, that should be view gear. Okay. There should be visible light. Okay. Theories of color and chemical constant, that should be cause of color of azotite. That should be first one, Witt's chromophore oxychrome theory. Chromophore oxychrome are responsible for color. How? That is chromophore, the color appears in compound owing to the presence of certain functional group, usually with multiple bond, that is having double Mainly double bonds. Mainly double bonds. So the color that should be appear because of compounds having so many double bonds. Okay. These groups are called chromophore. Okay. The derivation is from, okay, the naming is from Greek chromophores or color carrier. Chromo means color and phores mean carrier. Okay, color carrier. The term has been retained within an extended interpretation to imply any functional group that absorb electromagnetic radiation. That is must be any functional group that should be absorb electromagnetic radiation. We can say that is chromophore. Whether or not a color is thereby produced, that is C/C, that must be maybe absorb light, we can also call chromophore, but actually the range that should be in UV region. Okay, most of the cases, that is more number of double bond containing compounds are treated as chromophore. Okay, now we consider oxochrome. Oxochrome, there are certain groups which do not themselves impart color. They are not sufficient to have a color, but they increase the color intensity when they attach with some chromophore. Okay, there are certain groups which do not themselves impart color to an colorless compound. The colorless compound having oxochrome do not impart the color, but do increase the coloring power of chromophores. When oxochromes are attached with chromophore, they should be impart more color. Okay, and these are known as oxochromes, meaning increased color. As for example, OR and OH, because of their lone pair, that should be lone pair also delocalized with multiple double bonds. So that should be impart more color. Okay, color intensity increases. Now we consider, that is azobenzene, that should be colorless, that is chromogen. Okay, which having NCSC whole twice, that is oxochrome NCSC whole twice, that should be increased lone pair, and this lone pair that should be delocalized. That should be delocalized. Okay. That should be delocalized. Okay, that's why the color that should be occur yellow dye. That should be yellow. Yellow color produced due to oxochrome. Oxochrome due to not because of oxochrome, because oxochrome imparts the color intensity more. That's why the color goes to UV region to visible region. So we observe the color yellow. Okay. Now resonance. Resonance means delocalization. As for example, this type of delocalization of electrons can be occur. This is we call resonance, or we called this is called resonance. Okay, the larger the number of electrons involved in resonance, the smaller is the energy difference between the ground and excited states, right? When the electrons that should be involved in resonance, number of electrons involved in resonance that should be increases, the smaller the energy gap between the ground and excited state. So the more conjugation in a molecule, longer wavelength can be there. Energy that should be stability can be gained. As we know, number of electrons in conjugation increases, the energy difference between the ground and excited state that should be decreases. So molecule overall gets stability, and that is energy that should be decreased. As we know, energy anti-proportional to wavelength, energy decreased. As we know, energy anti-proportional to wavelength, so wavelength that should be longer in region. Okay. So deepening of color can be occur. As for example, beta carotene, there must be so many double bonds are there, so many conjugation can be occur. So number of electrons present in double bonds are more and more, much more. So that's why color that should be seen for beta carotene. Okay. Here we know, that is there must be C6H5, CH double bond CH, C6H5 is colorless. Here again double bond increases, so is again colorless. By this way double bond increases, so color deepening that should be increases. Okay, that is colorless first one. then is colorless. Then C6H5 CH double bond CH whole 3. C6H5 is pale yellow. Okay. Then C6H5 CH double bond CH whole 4 C6H5, that should be yellow. Last one C6H5 CH double bond CH whole 5 C6H5, that should be orange in color. So color deepening can be occur. Now we termed as VBT, valence bond theory. Okay. According to this theory, electron pairs of a molecule in ground state are in a state of constant oscillation. They always in oscillation. Oscillating motion can be there. So when placed in light, they absorb a photon of appropriate energy. Okay. So they should be excited. As energy absorbed, so they get excited. Okay. The wavelength of light absorbed depends on the energy difference between ground state and excited state of the molecule, right? As we know from before, that is wavelength of light that should be absorbed depends only on the energy difference between the ground state and excited state. So that smaller the difference, longer will be the wavelength. As smaller the difference, so greater stability, energy decreased, lambda, that should be longer in region. Okay, as for example, ethylene, there should be one double bond, C double bond C, one. So there must be colorless. But butadiene having two double bonds, more conjugation, more electrons in resonance, that is excited state and ground state energy gap decreased more. So energy lesser, so lambda increase. Okay. Okay. So that's why butadiene colorful. Okay. Now we call MOT, molecular orbital theory. In molecular orbital theory, an atom or molecule that should be excited when one electron is transferred from a bonding to antibonding orbital. Okay. That should molecule is excited when one electron that should be go from bonding to antibonding orbital. As we know, there must be atomic orbital, that is bonding orbital, bonding MO, and that is must be antibonding MO. Okay. Right? We know that. Okay. There are 4 types of electronic transition can be possible. As we know, that is selection rule, that is Gerard to Gerard, ungerard to ungerard only possible. Gerard to ungerard, I think not possible. So by this way, sigma is Gerard, sigma star is ungerard, pi is ungerard, pi star is Gerard. Okay. So Gerard to Gerard, sigma to sigma star are not beyond, basically here sigma to sigma star, pi to pi star, n to pi star, and n to sigma star can be possible. Here must be Gerard to ungerard, ungerard to Gerard, that should be permissible. Okay. Sigma is Gerard, sigma star ungerard, Gerard to ungerard. Pi is Gerard, pi star is ungerard, pi is ungerard, pi star is Gerard. Pi to pi star can be possible, but n actually does not undergo any type of Gerard ungerard category. So n to sigma star and n to pi star, that should be intensity low. Okay. There Planck's relation, E equal to h nu equal to hc by lambda. That is, E is the energy, h is the Planck's constant, nu is the frequency, c is the nothing but speed of light, that is must be 3 into 10 to the power 8 value, that is 3 into 10 to the power 8. Speed, I think centimeter per second. Okay. Lambda equal to wavelength. Diazotization, the formation of aromatic diazonium salt from primary the formation of aromatic diazonium salt. Diazotization needs to make amine and plus NNO2 plus HCl, that is nitrous acid, 0 to 5 degrees centigrade temperature, that is very much important, and acidic media. Okay, the diazotization can be performed in laboratory. That is, this can be often produced only 0 to 5 degrees centigrade and in acidic media. Okay. Okay. The mechanism of diazotization nothing but that is nitrous acid. Nitrous acid H2O, that is hydrogen abstract. So OH2 can be produced. OH2 removed. So NO nitrous O ion that should be produced. Nitrous ion that should be produced. Now this aromatic compound amine abstract nitroso group. Okay, so here water abstract hydrogen. Okay, there again water abstract hydrogen. Okay, and there we can say that is diazo hydroxide can be produced. Diazo hydroxide produced by this way. This produce and then this produce. Okay. Next one, by some arrangement we get ultimately diazonium salt. Okay, diazonium salt. Okay, nothing but nitrous acid first protonated in the medium of water, then water removed, then nitroso group can be produced and aromatic amine that should be react with nitroso group, and by some electronic rearrangement and potential deprotonation we get ultimately diazonium salt. Okay. Azodyes are various types. First one, monoazodine, that should be cationic dye. As for example, chirosodine. Chirosodine is a cationic dye. Is prepared by coupling benzene diazonium chloride with metaphenylene diamine. Benzene diazonium chloride with metaphenylene diamine. It is used for dyeing paper, leather and jute also. Another cationic dye is acid red. These are the example. The structure are one is chirosodine, that is benzene, N double bond N, that is this structure is there, and other is acid red, this structure is there. Okay. Then last one, methyl orange. It is prepared by coupling diazotized sulfonuric acid with NN dimethyl aniline in acetic acid. It is used as a dye, it is used as indicator also. Sometimes for titration or sometimes for physical chemistry lab performance we need methyl orange. Okay, for laboratory to detect the endpoint. Okay, so it is prepared by coupling diazotized sulfonuric acid with NN dimethyl aniline in acetic acid, and it is used as a dye, it is used as an indicator.